Hey, welcome back. Today we're going to be talking about how to take derivatives and integrate velocity equations using E and using the natural log. So E being Euler's number. So this is primarily for AP Physics C mechanics students. And really the purpose for today is just to become more comfortable with using a few special case scenarios for differentiation and integration. Alright, so just a super quick recap. I'm not going to do this whole recap, but if you have a position equation and you take the derivative, you end up with a velocity equation. And if you take the derivative of a velocity equation, you end up with an acceleration equation. And if you want to go backwards, you find the integral. So we've been talking about these ideas lately, and I just want to emphasize if you're taking the derivative of, say, a position equation, you're going to get the instantaneous velocity. And if you take the derivative of a velocity function or equation, you're going to get instantaneous acceleration. Now, when you integrate, you're actually going to get the change in value. So, for instance, the integral of an acceleration equation is going to give you the change in velocity, and the integral of a velocity function is going to give you the change in position or the displacement. So let's go ahead and get to it. The first problem we have says differentiate the velocity equation as written. So we could say, all right, well, what would this be? If we take the derivative of a velocity equation, what do we end up with? We end up with an acceleration equation. So we could just start by saying acceleration is dv dt. And so you could say dv dt of this 2e 7t like this is going to be equal to our acceleration function. We could find out what that's going to be. So if we look at the rule, this rule is on your equation sheet. Super important. So this is super important in the sense that you need to get comfortable using this equation, and it's on there for reference for you on the actual test. You just have to look in the back section of the back of like the first page, and you'll end up seeing a calculus section that will remind you of these things. So what we're going to do is notice that you have a coefficient as a power in front of this x, and that needs to drop down as a coefficient in front of the e, and then the e stays the same. In other words, e to the 7t power, and you would have to take the 2 that was there previously, multiply it by a 7, and that's going to be equal to our acceleration function. So that would be 14 e to the 7t power. That's going to be your answer for this problem. Pretty straightforward. Let's take a look at another example problem. So this problem again asks us to differentiate, to take the derivative of this velocity equation here. So what do we end up with? We could go ahead and start out by writing this. This is probably never a bad idea. I know that we're all under time pressure for the AP Physics C test, but sometimes you'll get a point if you just make it very clear to your grader that you know that the derivative of a velocity equation or function is an acceleration equation. So we could say, all right, well, acceleration is going to be... So let's look at the function we have. We have the natural log here of ax. Notice this a is our coefficient. It simply goes away. So that 33 is going to go away. What do we end up with? We end up with literally 1 over t, and that's going to be our answer for this problem. Pretty straightforward once you're comfortable with it. Let's try another problem with integration. Alright, so our third problem says find the integral of this equation right here. This is a velocity function. Remember, it's talking about the integral, so are we going to end up with an acceleration equation here or something else? We will end up with a change in position function, or a displacement function, you could say. This change in position is going to be equal to the integral of 2e6t dt. Okay, so that's what we're dealing with here. So we could say, all right, well, what do we end up with? Let's take a look at the rule. Notice that our coefficient in front of the power that we're working with in terms of our integral is going to go out front. So in this case, you're going to have a 2, which is what we started with, over 6, and that's because that's the coefficient in front of the t. Then we have e to the 6t power. This is a common theme. You're going to leave the power for e alone, essentially. And then we cannot forget the constant of integration over here. Since this is a indefinite integral, we need to add that in. That's going to be our answer. Oh, one more thing, actually, that's almost our answer. We can just simplify this, and we could say that's going to be our answer over here. All right, let's try one last problem and see how it goes. So it says find the integral of this velocity equation. So if we write the original equation and we take the integral of both sides, let's think about what equation we'll end up with. If you take the integral of a velocity equation, you end up with a change in position equation or displacement equation. Next, let's take a look at the rule that we have. Notice that this a is some coefficient. This x is the variable that we're integrating in terms of. So in this case, our t variable is going to take the place of our x, you could say up here. So what do we end up with? Well, we end up with the natural log, so that's an ln, of the absolute value of t plus 37. Notice it's pretty straightforward if you just follow the guidelines that you have on your equation sheet. At least to get started. Some problems do definitely get harder than this, but this is an introduction to be able to use the equations that have Euler's number and natural log in there with derivatives and integrals. I've done lessons on an entire year of physics and most of the concepts for an AP Physics C mechanics class. Hopefully this has been helpful. If you have any questions or comments down below, please let me know, and I hope you all have a great day. Take care.